Module A-1, Objective 5. Be able to read and apply the rules of chemical notation. The information can be found on Table 2-2, page 37 of your text. Rule number 1. When you see a symbol of an element, that indicates one atom of that element. H equals one atom of hydrogen. O equals one atom of oxygen. What would N indicate? What would C indicate? Rule number 2. A number preceding the symbol of an element indicates more than one atom of that element. 2H represents two atoms of hydrogen. 2O represents two atoms of oxygen. What would 3H represent? What would 25O represent? Rule number 3. A subscript following the symbol of an element indicates a molecule with that number of atoms of that element. Note the subscript 2 in H2O. H2O represents one molecule of water, but in a single molecule of water there are two hydrogens and one oxygen. So the subscript applies only to the hydrogen. In C6H12O6, can you figure out how many carbons, hydrogens, and oxygens there are? Rule number 4. In a description of a chemical reaction, the participant or participants at the start of the reaction are called reactants, and the reaction generates one or more products. An arrow indicates the direction of the reaction. From reactants, usually on the left, to products, usually on the right. In the following reaction, two atoms of hydrogen combine with one atom of oxygen to produce a single molecule of water. A superscript plus or minus sign following a symbol of an element indicates an ion. The single plus sign indicates a cation. Remember, cations are positively charged. A single minus sign indicates an anion with a charge of -1. The original atom has gained one electron. If more than one electron has been lost or gained, the charge on the ion is indicated by the number preceding the plus or minus sign. Na plus is a sodium ion. Cl minus is a chloride ion. And Ca2 plus is a calcium ion. And again, note that it's 2 plus, which represents that it has lost 2 electrons. Rule number 6. Chemical reactions neither create nor destroy atoms. They merely rearrange atoms into new combinations. Therefore, the numbers of atoms of each element must always be the same on both sides of the equation for a chemical reaction. When this is the case, the equation is balanced. We always need to be sure that our equations are balanced. In the example below, you'll see an unbalanced equation where hydrogen and oxygen combine to form water. The number of hydrogens in the reactants is 2. The number of oxygens in the reactants is 2. And the number of hydrogens in the products is 2. The number of oxygens is only 1. That is unbalanced. Which element is unbalanced? The oxygen. 2 does not equal 1. To balance the equation, we can't have half molecules, molecular oxygen is needed and molecular hydrogen is needed, and those are diatomic molecules, so you're always going to have two hydrogens or two oxygens. In this case, to balance the equation, we must add a 2 in front of the hydrogen. 2 molecules of hydrogen equals 4 hydrogen atoms. 1 molecule, there's an understood 1 here. 1 molecule of oxygen is 2 oxygens. In the products, 2 times 2 is equal to 4. 2 times an understood 1 is equal to 2. So you have 4 hydrogens to 4 hydrogens, 2 oxygens to 2 oxygens. That equation is balanced. Can you balance another equation? I'm going to give you a challenge. The equation is CO2 plus H2O yields C6H12O6 plus O2. Are you up for the challenge?